Assalamu alaikum, my dear students. Welcome to your chemistry class of Standard 9. Hope all of you are fine, safe and sound. Today, I will discuss about Chatellier's principle. Chatellier's principle is focused on the equilibrium position of reversible reaction. You know that reversible reaction is a reaction in which reactants are converted into products and again products are converted into reactants. But you have to know about equilibrium position. So today at first we will know about equilibrium position. In a reversible reaction, there are mainly two parts, forward reaction and backward reaction. When reactants are converted into products, this part is known as forward reaction, and when products again converted into reactants through reaction, this part is known as backward reaction. When the rate of forward reaction and backward reaction both are same, in this state is called equilibrium state of a reversible reaction. Follow this picture, then it will be clear more to you. These pictures actually different steps of a reaction. Our reaction is this, where A and B are reactants and C and D are products. In first state, what do we see? There are only present reactants. No products are present in first time of a reaction. So here rate of forward reaction is so high, collisions between reactants are also high, and reaction begins in this state. Now after some time we will see in second and third state products are starting to produced. Follow here, red and yellow color products are present in a small amount. Here gradually it is increasing. So forward reaction rate in these steps gradually decreases, but reverse reaction rate gradually increases, and collisions between reactants also gradually decreases. And finally we can see here the amount of reactants and products are in equal. That means the forward reaction rate and backward reaction rate both are same here. So this state we can call equilibrium position, where the amount of reactants and products are same because the reaction rate of forward and backward reaction is same. So this step or this state is called equilibrium position of a reversible reaction. So now we will know about some characteristics of chemical equilibrium. At chemical equilibrium, the concentration of each of the reactants and the products becomes constant because the amount of reactants and products are same, so their concentration is also constant. Rate of forward reaction becomes equal to the backward reaction rate. For this equilibrium actually dynamic in nature. This is continuous process. A equilibrium is established by only if system is closed one. That means the meaning of this line, system is closed one, the meaning of this line is actually here our reaction system should be closed. Why? Because if any gaseous products are present there, and if the reaction system is not closed, then if any one gaseous product is fly away, then backward reaction is not possible from this open system, because to occur backward reaction all products must be present over there. For this, reaction system should be or must be closed, since all products are present there if there is produced any gaseous product. But if the products are all are solid or liquid, in this case closed system not necessary, but for the gaseous products, closed system of a reaction chamber must be needed. Now, chemical equilibrium can be attained from both directions of reaction. Yes, because forward and backward both are occurring here, and it is not affected if any catalyst is used. That means there is no effect of catalyst in a reversible reaction on the equilibrium position. So these are the actually characteristics of equilibrium position of reversible reaction. Now follow this graphical representation of equilibrium position. If we draw a curve plotting between reaction rate with time, then we will get this type of curve. How? Follow here at the preliminary time or in the first time of a reaction, forward reaction rate is high and reverse reaction rate is lowest, isn't it? But when time is passing, then reverse reaction rate is gradually increases, forward reaction rate is gradually decreases, and once upon a time these two reaction rate are equal, and this is called equilibrium position. But if we plot a graph, if we plot between amount and time, then what will happen? Then we will get this type of graph. How? Follow here. In the first time of a reaction, the amount of reactant is highest and amount of product is lowest, because product is not produced, is not started to produce here, but after passing or after starting the reactions, then gradually the amount of reactants decreases and the amount of products gradually increases, and one upon a time or in equilibrium the amount of reactants and products will be same, no change in amounts. So this state is known as equilibrium position. This position is known as equilibrium positions. So I hope you clearly understand about the equilibrium position. Now we will know about Le Chatelier's principle. Le Chatelier's principle is that when a chemical system at equilibrium is disturbed by a stress, the system adjusts to oppose the change. That means when in any equilibrium position of a reversible reaction, if any factors such as factors here is termed is disturbed by a stress. Actually these are factors. Factors may be temperature or pressure or concentration of reactant or product, anyone. If we change the factor, that means if temperature is increased or decreased, pressure is increased or decreased, or amount of reactants or products decreased or increased, then the equilibrium position will shift in which side? Here Le Chatelier's principle actually states that in this case, that means in equilibrium position, if we change any factor, then the equilibrium position will shift in a side to neutralize or minimize the changed factor. That is the Le Chatelier's principle. Follow the another definition. Le Chatelier's principle states that if something is changed in a system at equilibrium, the system shifts in equilibrium position in order to counteract or oppose this change. Just in a word, equilibrium position is shifted in such a way that the changed factor, that means you increased or decreased the temperature or pressure, this changed factor should be minimized or should be neutralized. So this is actually known as Le Chatelier's principle. So you can write the principle in any way, no problem, but you have to understand perfectly. Now follow this picture, then it will be more clear about the Le Chatelier's principle. This lever actually represents the equation or chemical reactions, and now this lever is actually balanced. That means the reaction is in equilibrium position. If we add more in left side, that is in reactant side, then the lever will tip to the left. That means in this side it will be down, isn't it? So again, to bring the balanced position, that means if we restoring the balanced position, then what we have to do, we have to do something as if the more amount is increased in product side, then it will be balanced, isn't it? If we add more something in reactant side, then it will left down, and to become again it is balanced, then we have to doing something such as in the right side or product side more amount should be increased. Then in this case the position again will be balanced. So this is actually doing according the Le Chatelier's principle. Now we will discuss about the different factors on equilibrium position according to Le Chatelier's principle. At first, temperature. We will know about effect of temperature on equilibrium position. For here we will get two types reaction: exothermic reaction or endothermic reaction. Exothermic reaction means the reaction by which heat is produced, and endothermic reaction means the reaction by which heat is absorbed. So here what reaction we will be obtained, this is not a big headache. We have to just remember this to change the equilibrium position according to Le Chatelier's principle. Actually we have to remember this. If the temperature of the system is increased, that means if the temperature we will increase of that reaction, then the equilibrium position will shift in the direction of the endothermic reaction. That means if temperature is increased of the reaction, changed factor, that means if we change the temperature to increase, then the equilibrium position will shift to the direction of endothermic reaction. That means endothermic reaction rate should be increased. And if the temperature is decreased of the reaction system, then the equilibrium position will shift to the exothermic reaction. That means exothermic reaction rate will be increased. Follow this. Let us consider a reaction which is exothermic. That means heat is produced from this reaction. So here we know that when a reversible reaction is exothermic reaction, then its forward reaction is exothermic, but its backward reaction must be a endothermic. So in this case, if we increase temperature of this reaction, then what will happen? The endothermic reaction rate should be increased, isn't it? So equilibrium, and here the backward reaction is endothermic reaction, so equilibrium position will shift to the left side. Equilibrium position is of right side means forward reaction rate is increased, and left side equilibrium position is shifted to the left side means backward reaction rate increases. So since it is an exothermic reaction and its forward reaction is exothermic and backward reaction is endothermic, so in this case if we increase temperature, then since the endothermic reaction rate will be increased, so equilibrium position should be shifted into the left side. And if we decrease the reaction temperature of this reaction, then what will happen? Exothermic reaction rate should be increased. So equilibrium position equilibrium position shifts to the right side because its forward reaction is exothermic reaction. So equilibrium position shifts to the right side. Just you have to remember this. Follow the another example when the reaction is endothermic reaction. That means heat is absorbed by the reactants. So in this case, forward reaction is endothermic reaction, but backward reaction is exothermic reaction. In this case, if temperature is increased, then endothermic reaction rate should be increased. So forward reaction rate should be increased. So equilibrium position is shifted to the right side. And if temperature is decreased, so exothermic reaction rate should be increased, and backward reaction is exothermic, so equilibrium position shifts to the left side. So like this way, easily you can identify your equilibrium position through changing the temperature factor. Now I will discuss about the factors of pressure. Pressure, in this case, at first we will observe the amount of reactants and products, amount of moles of reactants and products. If there is difference, then the pressure factors is acted, otherwise there will not effect of pressure on this reaction. Follow here, in this reaction, the amount of reactant mole is 4. 1 mole nitrogen reacts with 3 mole hydrogen. So 4 mole of gas on the reactor side, but in product side only 2 mole gas. So there is a difference between mole of reactants and products. That means pressure is affected here. So in this case, if we increase pressure, then what will happen? Then if we increase pressure, then to minimize this increased pressure, equilibrium position shifted to the lesser amount of side, the side shifted to that side in which less amount of substance is present. So here if we increase pressure, then equilibrium position shifted to the right side, and if we decrease pressure, then the equilibrium position shifted to the left side. So like this way, the pressure factor should be maintained according to Chatellier's principle. Now we will discuss about concentration. Concentration, we can change the concentration factors in case of reactants and products both. That means, follow here, if we add more reactant, then equilibrium position shifted in which side to adjust this more reactant? That means equilibrium position shifted to the right side. Why? Because right side means forward reaction rate will be increased. That means reactants should converted into products. So like this way, the added amount of reactant should be minimized due to the decreasing of amount of reactant through the forward reaction rate. Now if we decrease the amount of reactants, then what will happen? Then equilibrium position shifts to the left side. That means the amount of reactants will be increased. Then conversely, if we add the amount of product, then what will happen? Equilibrium position shifts to the reactants. That means backward reaction rate will be increased, and equilibrium position shifts to left side. And if we remove the products, then what will happen? Equilibrium position shifts to the right side to increase the amount of products. So like this way, actually we will easily identify the position of equilibrium in a reversible reaction according to Chatellier's principle. Now once again we will review. If we increase the concentration of reactant, equilibrium position should be shifted to the right side. If we increase temperature of an endothermic reaction, then equilibrium position should be shifted to the right side. if we increase temperature of an exothermic reaction, then endothermic reaction rate should be increased, so equilibrium position should be shifted in the left side. If we increase pressure of gaseous equilibrium, higher forward reaction yields fewer moles of gas. That means product side moles number is less, so equilibrium position shifted to the right side. And increased pressure, higher moles of the gas are the same on each side of the equation, then no change in position of equilibrium, because there is actually not affected by pressure. And a catalyst, no change in the position of equilibrium, because equilibrium position is not affected by any catalyst. So I hope, my dear students, you clearly understand about the La Chatelier's principle on the equilibrium position of reversible reaction. But if the question may come like this way, explain the effect of temperature, pressure and concentration according to the La Chatelier's principle on the following reaction, then how will you write the answer? I will show here. This is very important question. Almost every year board exam this type of question may come. In this case, in any equation, exothermic or endothermic can be given here, but explanation should be same. So how can you write this answer of this question? Just I will help to write the answer here. At first you have to write the La Chatelier's principle, then you have to describe the given reaction. Follow here. Here the above mentioned reaction is exothermic reaction. How will you understand about the following, about the observing the value of del H? When the value of del H is negative, that is exothermic, and when the value of del H is positive, that is endothermic reaction. So the forward reaction is exothermic and backward reaction is endothermic. Now the effect of temperature, pressure and concentration on this given reaction will be discussed like this. Effect of temperature, just from here you use the language to which you help in writing the answer of this type of question. Effect of pressure, then you have to discuss effect of concentration like this way. Effect of concentration. But if the question may come like this way, how will you get maximum product from this reaction, from a given reaction? Explain according to La Chatelier's principle. Then how will you write the answer? Then you have to write this answer like this way. Similarly, you have to write from first to last. Just at last you have to add these lines. So from the above discussion, we can say to get maximum product from the given reaction, temperature should be decreased, pressure and reactant should be increased. That means in this given reaction, we have seen, follow here, if temperature is increased, then equilibrium position shift to the left side, that means increasing the product of reactants. But if the temperature is decreased, equilibrium position shift to the right side, so amount of products is increased. So to get maximum product, the temperature should be decreased. And from pressure we have seen here, if pressure is increased, then the equilibrium position shifted to the right side, that means the amount of products will be increased. So to get the maximum products, pressure should be increased. And concentration, in case of concentration, concentration of reactants should be increased to get the maximum product. Like this way you have to write the answer of this type of question. So today up to this, I hope you clearly understand. So for better understand, you have to follow this lecture more times. So today up to this, goodbye.